In this video, we'll be solving systems of equations using row echelon form. To ensure we are performing the least number of row operations possible, we'll be using a procedure called Gaussian elimination. So these are the steps for Gaussian elimination with back substitution. We're going to start by writing the systems of equations as an augmented matrix. Then we're going to perform one of our three legal row operations to rewrite the augmented matrix in row echelon form. And we're going to do it as follows. We'll start by creating a leading one in the first row, first column. Then we'll create zeros below the leading one in the first column. Once everything's taken care of in the first column, we'll move on to our second leading one. We want to create a leading one in the second row, second column, then create zeros below that leading one in the second column. Then we move on. Leading one, third row, third column, zeros below. Leading one, fourth row, fourth column, zeros below, and so on until our augmented matrix is in row echelon form. Then we'll write the system of linear equations that corresponds to the matrix in row echelon form. And lastly, we'll use back substitution to solve the system of linear equations. So let's solve this 2 by 2 using Gaussian elimination. The first thing we want to do is rewrite our system of equations as an augmented matrix. Our first row will be 3, 2, 11, and our second row will be 1, negative 1, 12. Now we want to get a leading one, first row, first column, right here where the 3 is. We have two options. We can either interchange two rows or multiply through by some number, and it's usually a fraction that we multiply through by. So I could multiply 3 by 1/3 to get that leading one there. However, that would create fractions in the rest of the row. So I would prefer to use the row operation of just interchanging row 1 and row 2 to avoid the fractions. It just makes our life easier in the long run. Be sure to write the row operation in between each of your matrices. Not only is it going to help you follow your work, but it's going to help your instructor follow your work as well. So we're simply flip-flopping row 1 and row 2. I always double check my writing as well. It's real easy with these types of problems to write the wrong number down or interchange something, so I recommend always double checking. Great, we have our leading one, first row, first column. Now we want to get zeros below that leading one, so we need to turn the 3 into a 0. We're typically using our third row operation to create zeros. That third row operation says we're going to multiply a row by a non-zero constant, add it to another row, and replace that other row. It's going to follow a pattern, so this is how you figure out the row operation. The first thing you want to do is ask yourself, well, what do I need to add to 3 to make it 0? Negative 3. So that's going to be our multiplier. We next ask ourselves, well, what row is that leading one in the first column? The leading one in the first column is located in the first row. So we're going to multiply the first row by that negative 3. Another way to think of it is you can just ask yourself, what column am I working in? Column 1, so you always multiply row 1 when you're in column 1. All right, so we have negative 3 times row 1. Now we're going to add it to the row that we want to change, which is row 2, and that'll be our new row 2. The only row that's changing is row 2, so I always rewrite the rows that I'm not changing down right away. And now we need to perform this row operation. I recommend doing some side work. So we need -3 times row 1, and then we're going to add it to row 2. So -3 times row 1 is -3, +3, -36, and we'll add that to row 2 as is. And when I add this together, that will be my new row 2. So we get 0, 5, -25. That's our new row 2. Our first column's taken care of. We have a leading one first row, first column, and zeros below. Now it's time to move on and get our second leading one, which would be in the second row, second column, right here. So we need this 5 to turn into a 1. Our two options are to interchange two rows or multiply through by usually a fraction. Well, you don't ever want to interchange with the row above the one you're working in. That's going to undo all of the work that you did in the previous column. To turn this 5 into a 1, we are going to multiply by 1/5. Our row operation is 1/5 times row 2 to give us a new row 2. I'm going to write my first row down since it's not changing. And now I'll think about row 2. 1/5 times 0 is 0. 1/5 times 5 is 1. And 1/5 times -25 is -5. We have our leading one, second row, second column. But there aren't any rows below it to get zeros in. So let's double check, make sure it's in row echelon form. Just go through your 4 characteristics. If there's a 0 row, it needs to be at the bottom. Well, we don't have that. The first non-zero entry coming in from the left is a +1. Yep, those are our 2 leading ones. The leading one in the row above is farther to the left. And lastly, below any leading ones, we have zeros. So this is in row echelon form. At this point, we want to rewrite the equations that go with this augmented matrix in row echelon form and back substitute to solve. Our equations will be x minus y equals 12 and y equals -5. We already have one solution, y equals -5. I'm just going to take that -5 and plug it into the other equation for y and solve for x. I'll have x minus a -5 equals 12. That's x plus 5 equals 12, making x equal to 7. There's our second solution. Remember that what we're solving is a system of equations, and we always want to write our solution as an ordered pair. Our final answer is the ordered pair 7, -5. Let's look at another example. A 3 by 3 this time. We're going to start the same. Write the system as an augmented matrix. Each equation gives us a row in our matrix. I'm just double checking that I wrote all my numbers down correctly. All right, looks good. Following our Gaussian elimination, the first thing we want is a leading one, first row, first column, and we have that already. Next, we want to get zeros below the leading one in that first column. One of the numbers is already a 0, but here we are, third row, first column. That number needs to be turned into a 0. We're using our third row operation. We ask ourselves, what do we add to 1 to make it 0? -1, that's our multiplier. The leading 1 in this column is in the first row, so we'll be multiplying the first row by that -1. We're going to add it to the row that we're changing, which is row 3, and we'll have a new row 3. I'll rewrite my equations that I'm not changing, my rows. And we'll do a little side work to figure out what our new row 3 is. I'm going to take -1 times row 1 and add it to row 3, and that'll be our new row 3. -1 times row 1, -1, +2, -3, -1, and we'll add it to our row 3 as is. We get 0, 2, -2, and 8. There's our new row 3. So our first column is taken care of so far. We have a leading 1, first row, first column, and then zeros below that. The next step in our Gaussian elimination is to get a leading 1, second row, second column. Right here. Great, we already have the 1. Therefore, the next step is to get zeros below that leading 1. I need to turn the 2 into a 0. We ask ourselves, what do I have to add to 2 to make it 0? -2, that's our multiplier. This time, the leading 1 in this column is located in row 2. So we'll be multiplying row 2 by that -2. We'll add it to the row that we want to change, which is row 3, and that will be our new row 3. Row 1 and 2 are not changing. Let's write those down. And we'll do some side work to get our new row 3. So we're doing -2 times row 2, adding it to row 3. -2 times row 2 gives us 0, -2, +2, -4. Adding that to row 3 as is, we get 0, 0, 0, 4. There's our new row 3. At this point, our second column is also taken care of. We have a leading 1, first row, first column, zeros below. Now we have a leading 1, second row, second column, zeros below. Is our matrix in row echelon form yet? Gaussian elimination says we should now get a leading 1, third row, third column, but wait a minute, there's a 0 there. So let's see, is this in row echelon form? Let's go through our 4 characteristics. Characteristic number 1 says if there's a 0 row, it's at the bottom. We do have a 0 row, and it is at the bottom. Next, for the rows that aren't all zeros, is the first non-zero entry coming in from the left a +1? Yes, it is. Those are our 2 leading 1s. Is the leading 1 in the row above farther to the left? Yes. And lastly, do we have zeros below all of our leading 1s? We do. This matrix is in row echelon form. That means that we're ready to rewrite our equations and back substitute to solve. The first equation is x minus 2y plus 3z equals 1. Our next equation is y minus z equals 2. But this third row looks kind of weird. Remember that all those zeros mean 0x plus 0y plus 0z. If I add all those zeros together, I get 0 on the left side of this equation, and it's going to be equal to 4. Well, what do you know about that statement, 0 equals 4? Yeah, it doesn't. 0 does not equal 4. This is a false statement. Anytime you're solving any type of equation and you end up with a false statement, that means that there is no solution to that equation. This system of equations has no solutions.